Today I'm running differential item functioning. And so in order to do that, I'm just going to go ahead and get started. Um, the first thing I needed to do was to install the package diff R. I've already installed this package, but the install packages function does that. Um, Next, I need to load my libraries. And so I need to load um, the diff-R library, the LTM, and the read XL. That is for the differential item functioning that I'm going to run. LTM for the latent trait models so that I can run a unidimensionality test, and the read XL file so I can get the data off my computer. So I'm going to library these. It didn't do much down here in the console because they were already libraried. So next I need to load my data. I'm going to do that with the read XL function, and I'm going to hold my data in the IRT data object. This right here is the location on my computer where that data can be found, so I'm going to run this. I see that it is attached here, 637 observations of 5 variables. And here I'm going to view that object, which is the data. So as you can see here, I have 5 variables. 4 of them are items, and 1 is a column of gender, where 1 is equal to male and 0 is equal to female. For the items, 0 is equal to incorrect and 1 is equal to correct. So in my scenario, I am analyzing using differential item functioning to look at a cognitive ability test and to see if this test is biased between genders or biased to one gender. And so that's the purpose of me running this test. So now I have my data loaded, and I'm running a 1 parameter latent trait model. So I'm going to use, first I need to create my rash model. So I'm going to use the rash function using my data, the IRT object, and I'm just going to hold it to rash. So I'm going to run that, and then I can look at it and make sure that I do have a model. So I do, just gives me some general information about my model. So the reason that I made this model is because I need to check for unidimensionality, which is one of the assumptions when you do differential item functioning. And so I need to test that test for unidimensionality, which just means that one latent trait is what is being measured. So I'm going to use this function, which is the unidim test, to rash and IRT data. Oh, I'm sorry. From the rash model using the IRT data. And this will check that assumption. So I'm just going to run it, and it does take a second to run. And so now I have my output. So the first line of the output is just tells me what the analysis was, and it tells me how, the information that it used to run it. It gives me a matrix of the tertichoric correlations, which is the inferred Pearson correlations, and the conclusion from what it tells me. So here, the conclusion that it has based on these results. So it used 100 Monte Carlo samples, and the value was significant, which means that this is not the best model to be using. It means that I do not have unidimensionality, but for the purposes of running my differential item functioning, I'm going to go ahead and use this. So my next step is going to be to use the diff lord function, and this calculates differential item functioning using the Lord's test. So the parameters of this test is going to be the IRT data. The first argument is for my data. Now, the group that I'm interested in, the group is gender, and so this means my referent group, the group that I'm analyzing to see if there are any differences. The focal name of that group I'm using is 1, so we're looking to see 1 was for men, so I'm telling it to look to see if there's differences between the men and women. The model that I'm using is the 1PL, which is the rash model, the alpha. So the significance level at 0.05, and the engine that is using is the latent trait model. I'm going to hold all of this into the Lord R object so that I can print and plot it when I'm done. So I'm just going to run that, and so this tells me that it's been run. So the first thing that I can do is print the object. And so the first line of the output that it gives me is that it tells me what the model was without purification. So I didn't use that argument to purify unused items. The engine was, and so this just tells you, reiterates all the things that I used in my model on the top. It provides the output and the Lord's chi-square statistic for each item. So this is the statistic, the column of statistics and the column of the p-values, and all of my items were significant. What that means is that all of my items using the Lord's test are showing differential item functioning. It just says this again and says that items 1, 2, 3, and 4 are detected as diff items. And then it gives the effect size. So item 4 had the largest effect size. Items 1, 2, and 3 was medium. So I'm going to plot this for a visual representation of what this output means. And so here in the plot area, you can see that all of my items ended up on top of the threshold. Item 4 has the highest, which it did have indicated that it had a larger effect size. So what I would do with this information is I would need to go and look at the items and see in what way they are biased against men. I would definitely recommend rewriting the items after seeing if they are biased and trying to find out why it is more difficult for men to answer or to get these items correct. Thank you.